Friends, this is Mr. Rahul Hunkalas, Assistant Professor and Workshop Superintendent from NB Navle Sinhagad College of Engineering, Solapur. My specialization in Mechanical Design Engineering. In this video, we are going to understand the next point in the topic of combustion in SI engines. In last video, we understood the meaning of knocking or detonation of SI engines. Here, we have to must understand the different effects of detonation on the engine. The first very important effect of detonation or knocking in the SI engine, that is, it creates a more noise and roughness of the engine operations. Then because of the detonation, there will be a different mechanical damages for the different components of IC engine. More carbon deposit can take place. Then increase in the rate of heat transfer from the engine. This is a very important effect of detonation. Then decrease in the power output. Pre-ignition may occur. These are the different effects of detonation. Pre-ignition is nothing but before the timing of the ignition, whatever ignition will happen inside the engine cylinder, that is called a pre-ignition. These are the different effects of detonation on SI engine. Now, how we can control the detonation? Now, with the help of this, here we can understand the control of detonation. The very important first point, we can control the detonation by increasing the engine RPM, means we can increase the RPM of the engine. Then retarding the spark, means we can set the timing of the spark ignition. Then we can reduce the pressure inside the engine cylinder or in the inlet manifold by throttling letter, means this is related to supply of air fuel mixture inside the engine cylinder. And fourth one, making the air fuel ratio too lean or too rich. This is about very important control of detonation. Now finally, here we can understand one of the important control of detonation, that is use of high octane fuel can eliminate detonation. High octane fuel are obtained by known as dopes such as tetraethyl of lead, benzoyl, xylene to petrol. In this case, use of a good quality of a petrol, that is also called as a high octane fuel, is very important to control the detonation. These are the different control methods of detonation in the case of SI engine. Now after this, there is very important point of our discussion, that is influence or effect or different factors which affect the engine variable on knock. This is very important question as per your exam question. There will be a 6 to 8 marks will be there for this particular question itself. Now the first factor which affect the engine variable on knock, that is called as a density factor. After this density factor, it includes the compression ratio of the engine, induction pressure, inlet temperature of the mixture, and then the mixture strength. After the mixture strength, it is again temperature of combustion chamber walls, retarding the spark timing. G point, that is power output of the engine. These all are comes under the density factor. This is the first factor which affect the engine variable on knock. Now the second factor, that is the time factor. Under the time factor, the very important sub factor, that is the turbulence of the air fuel mixture inside the engine cylinder. Then the engine speed, flame travel distance, how long the flame may travel inside the engine cylinder, the size of the engine, it may big, it may small. Then the combustion inside the engine cylinder as well as the combustion chamber design. Then ignition timing, and the last one, that is the cooling of the cylinder. These all points comes under the time factor. The third factor, that is the composition factor. Now in this composition factor, the sub factors are air fuel ratio, then octane value of the fuel. These all three factors along with their sub factors are very important which affect the engine variable on knock. Now after this, we have to understand the requirement of good combustion chamber. Now what is the meaning of combustion chamber? Now combustion chamber is a chamber where the process of combustion takes place. That chamber is nothing but what is a combustion chamber. We can see in every engine there is one casting, is it right? Now that casting, inside that casting, the piston and cylinder is there, the cylinder head is there, and that chamber is nothing but called as a combustion chamber where actual burning takes place. Now what are the different requirements of a good combustion chamber is again very important point. The first requirement of every good combustion chamber for SI engine, it should provide a high power output, then it should give a high compression ratio, then under the small or no excess of air, then complete utilization of air, optimum degree of turbulence, high volumetric efficiency, then all these points comes under the first one, high power output. In the second one, high thermal efficiency. Under high thermal efficiency, the first point is high compression ratio, small heat loss during the combustion. C point, that is a good scavenging of the exhaust gases. Now this comes under high thermal efficiency. Now the third point, that is smooth engine operation. Under this, the first one, moderate rate of pressure rise during the combustion, compact combustion chamber, proper location of the spark plug and exhaust valve, and satisfactory cooling of spark plug point. These all points comes under the requirements of good combustion chamber. Now the chamber which fulfills all these requirements, that is become a good combustion chamber for a SI engine. Now there are different types of combustion chamber. The first one, T head combustion chamber, second one, L head combustion chamber, third one, F head combustion chamber, and fourth one, that is a divided combustion chamber. Here we will understand one by one. The first diagram you can see on your screen, that is called a T head type combustion chamber. Actually, this T head type of combustion chamber was first invented in the year of 1908 by the Ford Motor, and they have used such kind of a combustion chamber in their famous car model T. Why it is called the T head combustion chamber? If you see, the combustion chamber design is just like a letter T. It has a two separate valve, inlet valve and exhaust valve in the head of the combustion chamber, along with the two separate camshaft for opening and closing of the valves. That's why this is called a T head combustion chamber. Now the second one, that is the L head combustion chamber. If you see in this diagram, the two valves, inlet and exhaust valve, it present at only one side of the cylinder, or we can say at only one side of this particular combustion chamber. So there is only one camshaft is used to opening and closing of this particular valves in the case of L head type of combustion chamber, and its shape is just like a letter L. Now the another model of L head combustion chamber by Ricardo's, and it is called the Ricardo's Turbulent L head combustion chamber. Mr. Ricardo again modified some things in the L head type of combustion chamber. If you see in the diagram, there is something changes in this upper section or head of the combustion chamber. Because of this, more turbulence takes place inside the combustion chamber. This is called Ricardo's Turbulent combustion chamber. Now when we are going to see the next type of a combustion chamber, that is the I head type of a combustion chamber. If you see in this diagram, the valves are fitted in the head of the combustion chamber. Both the valves, inlet valve and exhaust valve, are fitted in the head of the combustion chamber, and its shape is just like a I. That's why it is I head combustion chamber. When we see the F head type of a combustion chamber, in this case, one valve, that is the exhaust valve, is fitted in the head, and another valve is fitted in the body of the combustion chamber, and it's shaped just like a F head type of combustion chamber. These are the different types of the combustion chamber. I think you understood well manner. Here we stop in this lecture. We will come with another lecture with the help of the different things. Thank you.